by circling the part that looks more complex. And typically it's inside the parentheses, and whatever has more value of, that's going to be what our u is going to equal. So I want you to write on the top the following. Let u equal x squared plus 1. And if you were reading the instructions on the left-hand corner, it says then derive. And I'm going to write the 1 as an understood 1. What is a derivative of 1u? 1, and I'm going to write du. It is always derive d that letter. The next one, what is a derivative of x squared plus 1? 2x, and again, dx. And I need that because at some point, we're going to substitute that in. So then, with my green highlighter, I am going to highlight the piece that is identical. 2x dx does exist on both. Is everyone good with that? So when I plug it in, I am going to get the following. I have the integral, and I'm just rewriting the statement with the substitution. And what I circled was replaced by u. So let's write out u. There's a square, and all of the 2x dx is going to be replaced with du. So we're simply substituting in what we have on the right side from the original. So at this point, let's go ahead and integrate. So we have 1/3 u to the 3. And what do we always add at the very end? Plus c. And we're pretty much done, except the original problem was not in terms of u. So all we need to do is substitute back what I had in terms of u, x squared plus 1, all cubed plus c. So if you were reading to your partner the story on the left, and that did not make sense, this is all it was trying to tell you. Just replace it. So the way I want to kind of go over this notes will be in this order. Let's do this first. That's second. So we're building it up slowly. Third and fourth. So here we go. So typically the u that we're going to substitute in is almost always in parentheses. When there are multiple parentheses, we'll deal with that when we get to it, which we're going to get to on number 4. So all that is going to be our u. So let's write off to the side. U is equal to x squared plus 1. And if the 1 helps, write it out. What was a derivative of 1u again from the one above? 1 du. And what was a derivative of all that? 2x dx. Now, here's our problem on this one. I know I see x over here and dx, which I do right here. But what is interrupting that side of the equation? Is there a 2 on the original problem? So I need to get rid of it. So can I divide it by 2 on both sides? Yeah, so when I do, I get 1/2 du is equal to x dx. So using my highlighter, let's see what I have on my right is what the original question has. So time to substitute in what I have. So here's my integration. In place of all that was replaced with u squared. And what I have in green is going to be replaced with 1/2 du. And then at this point, if you have any fractional value or whole numbers, you are allowed to bring that to the front. Okay? So let's go ahead and bring it to the front. And then just rewrite the whole piece. U squared du. And since I brought the 1/2 over, I'm going to leave that alone. Now let's integrate. U squared is 1 over what? 1 over 3. U to the power of what was it? 3. And what do we always add at the end? Plus c. So our final answer when I plug in the u value. And let's compute 1/2 times 1/3. Isn't that 1 over 6? Yes? So we have x squared plus 1, all cubed, plus c, and that is our final answer. So there are cases when you do derive, there may be an extra piece. If you have an extra piece, get rid of it by moving it to the other side by doing simple algebra 1. Okay? So let's go on to number 4. It'll be our number 2. What do you think I'm going to do when I see a square root? We're going to go ahead and make it to 1/2. Rewrite it. So I see 2x minus 1 to the 1/2 dx. So what does your gut say about let u equal what? 2x minus 1. Let's do that off to the side. U is equal to 2x minus 1. And we know that's going to give us 1 du equal to 2 dx. So let's see if that is true. I have dx, which I do. What do I need to get rid of? The 2. So I'm going to go ahead and divide it by 2 on both sides. 1/2 du is dx. And now if I compare to the original to the final, I get dx is all by itself. So let's rewrite. Yes, ma'am. Thank you. Trying to see if it affects this period. Oh, it's the next class. All right. So let's go ahead and rewrite. We were integrating u to the 1/2, and then the dx was replaced with 1/2 du. So we're just simply rewriting the original problem. Let u equal to, dx was 1/2 of du. What are we going to do with the 1/2? Bring that to the where? To the front. So we have 1/2, and then just copy the integration. And now let's integrate, leaving the 1/2 alone. We have 1 over. What is our new power when I add 1 more to that? 3 over 2. U to the 3/2. And what do we always add at the end? Plus how many? Plus c. And I want to do this piece first. So we need to multiply by the reciprocal. So when I do, I get 1/2 of 2/3 u to the 3/2 plus c. And what do we notice about the 2 on the top and the bottom? They cancel. So I get 1/3. And let's go ahead and plug in the u while we're at it. And I'm out of room, so why not? 2x minus 1 to the 3/2 plus a c is our final answer. So having that single variable u is much, much easier. So here's more of an algebra piece. So let's do some with the trig function. Is everyone good with this right here? If you're still writing, I could wait. Okay, give me a thumbs up if you're good. Good, good. All right. Let's go on to my next piece. That's my number 3. And I want to rewrite this. I want you all to rewrite this in the following manner. Let's write out integration of cosine of 5x dx. Whether we have it this format or that format, they mean the exact same thing. I like this format because a calculator, when you plug in cosine, by default, it brings in a parentheses. So let's circle the part that's inside the parentheses, and we're going to let u equal 5x. So if I take the derivative, we get du is 5 dx. Is everyone good with that? So let's compare. I have dx, but I don't have 5 right next to the dx. So I need to go ahead and divide it by 5. So 1/5 du is equal to dx. So now I can go ahead and plug them in. So let's rewrite the original question in terms of u. Integration of cosine u du. And what do you think I might do to this without writing it right in front? Can I automatically bring it to the front right here? And at this point, let's see if y'all remember. Cosine integration is what value? Sine, very good. So I'm going to leave the 1/5 on the outside. We have sine of u plus c. But then, of course, our question was not in terms of u, so I'm going to plug in what the u was. So we have 1/5 sine of 5x plus c, and that's our final answer. Oh, that's an ugly 5. All right, now let's get to where we have a parentheses and another parentheses. So we know which one to let u equal. On number 3, I want you to rewrite this in the following form. The integral of sine of 3x all squared times cosine of 3x dx. Oh, do I have room? I don't know. We'll see. All right. So at this point, which one are we going to let u equal? If I let u equal 3x and I derive that, is that going to give me anything of the trig? So you need to take the bigger one that looks more complex and let u equal that. And let's see if I can fit it up here. Oh. You know what? I'm going to go down here and see if I can fit it. U is equal to sine of 3x. Now, if I were to derive the right side of this, isn't that chain rule? So here's a reminder of the chain rule. First of all, we know we have du. What is the derivative of the outside? Derivative of sine is cosine, and you leave the inside as it is. And then you derive the inside, which is 3dx. So let's see if I have all that piece. I have cosine 3x, so that's good. I have dx, that's also good. What do I not have? The 3, the whole number, let's go ahead and bring it to the front. Or by the front, I mean divided by 3. So 1/3 du is equal to cosine of 3x dx. So when I underline the pieces I have, that is identical. It's going to match up. So let's rewrite out the integration over here. So we have the integration of sine of 3x was replaced with the u. And then we have the 1/3 du. You guys okay if I put the 1/3 in front already? Yes? All right. Now let's integrate. The 1/3 comes straight down. From the u squared, when I integrate, I get 1/3 u cubed plus how many? What always goes at the end? The c. So when I simplify and plug it in, I get 1/9. And u is going to replace with what I had right here, sine of some number, sine of 3x cubed plus c, and that is our final answer. Now, we're not going to do the checking part, but if you were to check this, here's all you have to do. From your final answer, if you take the derivative, if you derive it,